Hello everyone, it's Peter here, Piotr Fissner from Inte.Team, guys. So, we received start dead batteries charger for repair. Booking 1922. We will be changing booking system into more modern, better one, which will have different names. So this year we will do it. Now this came that it was wrongly plugged in, so we can assume that something is shorted inside. We've got here industrial PCB, which is a trailer module. Yes, TM009 trailer module, UFC, and I couldn't find the fault until I started to test relays. When I started to test relays, the smell is in the room till now, so that wire has jumped and caused the problem. Now we will get to that one probably eventually as well, but what we can do with it, like first foremost, what we can do is that goes to the battery, so that's a jump start. Yes, and here looks like USB-C. Let me get my glasses. Yep, that's a USB-C. USB in out. Okay, so that's in out, and that's regular USB, not USB-C, but the regular one. So because we know it's a the battery is dead, the flashlight has given some signs, but that's all there is. Oh, we've got the power. So it is showing the power. So it's not completely dead. It's maybe the protection circuitry have kicked in, but okay, that's one. That's two. No. Let's do volts. Check volts. Okay, off. One more time. 0.6 volts. Okay. So does it take any charge? Let's get one USB wire from here or from here. Okay, yes, we know. Now which side is with the display, so we can see the wattage here, not only on the meter, or not only on the station. Okay, so it's here and now it's here. You see it's 0 volts at the moment. And when we plug in, still 0. That didn't change. Power delivery wattage 0, but it is showing charge. And my meter doesn't show any charge. Now it's off. Three watts. Three watts takes. And that's blinking, like dimming and powering on back again. And that takes 3 amperes. I mean, sorry, 3 watts, not 3 amperes. And here is showing 9.1 volt and 5 amps on this. I'll pause and I will go to my second. That one has power delivery as well, and Q and other stuff, so we will see what the second one will show. Okay guys, so I did take to the second power supply, and power delivery was switching to 20 volts and up to 0.2 amps. So yeah, it wasn't great, so I start to open it. Yes, and you need a triangle screw size 2, but somebody's calling. Okay guys, so I had to switch to the how you call it, to the manual one, because for electric one was too fragile, but manual did what we supposed to do with the electric one. So let's see what it holds inside. Yes, doesn't wanna go too easily. Nothing is holding us back, so in theory that should go. Oh, okay, that's a gasket or some washer or whatever it's here, because that's IP56 or something. IP65, sorry, 65. So that has to have good insulation. Okay, can hear something ungluing. Ooh, that design is not something I would like to see here, but well, hey ho. So what do we have here? Here we've got electronics with everything which steers the device. Here we've got a battery pack, and here we've got some relays or something. Yeah, that's looking like relays to switch it on. So the battery pack, electronics, and then the wires here as well. Okay, so what we can start off is disconnecting this, and then disconnecting this, but that goes to the battery, that won't be disconnected easily. So the only thing what we can focus on is one, to see if the battery has any voltage. Yes, any voltage or not. Let's switch into the volts. You can see something, you might not see anything. Okay, now let's see here and here. 12 volts. Okay, so the battery wasn't shorted, that's why we see it powering on somewhat. Yes, somewhat. Now I doubt that's a voltage source, that's probably either a sensor or something. Yes, what it is, battery plus 16 volts. I doubt that it's like, okay, that can be just test for charge. Maybe that's, you know, I didn't open a battery, maybe it's some sort of like a BMS, battery management system. What else? Do we have any power anywhere? That's black wire. Okay, so that's nothing. Nothing on this one. Now here are two black ones. Oh, that's 12 volts. That's 12 volts. That's 6 volts. That's 2.9 volt. Okay, so that's more of like a BMS. Okay, so before we test on the board anything, we need to check for shorts. And I won't be connecting anything yet. Okay, so let's check those random capacitors here. Okay, cool. So on this side doesn't look like there are any shorts. That's our USB-C. That's the diode. Okay. Ooh. Okay. Diode has 0 ohms. It doesn't let go on this side. Why 0 ohms? Okay, so what it is that sometimes you've got diode and a resistor, and if at the bottom will be a resistor which will be low ohm resistor, which there are certain circuits even in half bridge or somewhere, you know, in the power supplies, where you've got diode and the resistor parallel to each other. And in that case, if there's anything hidden underneath, I might be wrong with my diagnosis that the diode is, but it's open circuit completely, 0 ohms, and on this side is completely closed. So if you've got a resistor parallel, that would still show low ohms on either side, so that's not the case. But that's 0 ohm this way, so how come? In that case we need to take it out. Now if this was connected wrongly, plus and minus, then that, from the design, I see that that goes to this lithium battery. So if these were connected plus to the minus and minus to the plus, but the charge is here, so the charge should charge via those yellow and black wires. So black, I assume, will be positive. I mean, black will be negative, sorry. I don't know where I am with my head. Yes, exactly, and that will be the opposite. Minus, exactly. So what we can do is we can set up 12 volts, maybe not 12, but 13 volts, because that's 14.8, so no more than, we can do 13 volts. We can do over current protection. We can take those here and see if that will consume any power. So black to black, red to red. Okay, OCP, so over current protection is on the power supply, and that in theory should take some amps. OCP. Okay, so over current protection. Okay, so let's do less. Let's do like 3 volts. No overcurrent protection. And small amperage. We don't need 10 amps, yeah? Okay, let's do 1 amp. Ooh. Okay, it's doesn't show. Ooh, wanna spark here. Doesn't take any amps and doesn't short. Okay, so it's just the battery, so it's internal part. Okay, so I will disconnect. Now I will hook up. Oh, now 1 amp is taken. 1226, 1227, 8, 9. So guys, you don't see it, and I don't want to take the camera, but it's 12.33, 12.34, 12.35, 36. So it is growing. Yes, I don't have any mirror here to show you, but the voltages are growing, so the battery is alive. The battery is alive, so I can charge the battery. So that means the battery is taking current and doesn't stop it. So in that case, the circuitry here has been burned, or the BMS over there, which then use probably these wires to control the battery. Yes, 12.5. Okay, I can just assume that it's fine. So that was 12.0, and now is, oh, I can check. Can you see it? You can see it. Now it's 12.36 exactly. So it is growing. It is fine. So because the voltage is present on the battery, because we see, you know, that there's no short here, we need to find short somewhere, somewhere from the battery side to the connector here, which is inside the battery. And do we have a short? I doubt, but do we have a short in between these? No, 0 ohms. Okay, so because we've got 0 ohms, that's good. And now in between red and the yellow here, do we have a short? Yes, that's short. And now in between black and black, nothing. Okay, so they are either not internally connected, or there is some problem and something only damaged the battery. So do you know how we could test it? We could test it the way that I would remove this battery and check only how it is connected internally, so we would understand the BMS, and then we could connect different battery with different BMS and then test it. If the device is working fine, we know the problem is with the battery, which has BMS, and then we would look only into the BMS, because battery takes charge. If there is a problem with the BMS, we can then either fix or replace the BMS. And then that would be a full fix, yes, but that's the goal. I need to open it more, check it from the other side, check why this diode is, you know, like 0 ohms completely from anode to cathode, and then I can do another maybe episode if I will find anything interesting about this device. Okay, but for now that's everything. I don't want to take more of your time. Look, it's already 17 minutes. Yes, so guys, thank you for watching. If you would like to fix electronics, or you would like to run your own repair shop of electronics, you can let us know. We're helping people to start their repair shops from working from home. Thank you guys. Bye bye.